and depression. So these are word problems, and we're still using our trig functions for sine, cosine, and tangent. And in these word problems, it's going to be referring to either an angle of depression or an angle of elevation. And what you need to know on all of these, you're going to be forming a right triangle. And the hardest part is just setting up your triangle. That's it. And then, of course, you need to remember, which one to use, either sine, cosine, or tangent. So in our diagram up here, you need to be able to set up your right triangle. So your right triangle is either going to be formed up in the air. So here. So you could have a right triangle up in the air, or your right triangle could be formed with the ground. Okay? So an angle of depression is going to be like up in the air, and it's going to be formed like in the air going down. Okay? If it says angle of elevation, you think going up. Okay? So it's the ground going up. Okay? So depression is going down. So you kind of think if you're depressed, you're down. Elevation is going to be going up. Okay? So that is the difference. And then once again, remember our trig functions, sine, cosine, tangent. So once again, remember our saying that we learned. Some old hippie caught another hippie tripping on acid. And that gives us sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And that'll help us decide whether we're using sine, cosine, or tangent. So our first word problem that we're going to use, a ship is just offshore of New York City. A sighting is taken, of the Statue of Liberty, which is about 305 feet tall. Okay, so we've got our Statue of Liberty, which is 305 feet tall. Here's the ship, which is just offshore of New York City. Here's our right angle. So we've got our triangle here. The angle of elevation. So remember, the angle of elevation is going up. The ground up, or actually, in the water. So there's our angle here. Is 20 degrees. So there's our 20 degrees. How far is the ship from the statue? Okay, so here's like the base of the statue. Here is the ship. We want to know how far it is here. Okay, so now I need to figure out, which trig function we're using. Okay, so you use what you know and what you're given. So the angle going across the triangle, well, what is this? In relation to the angle. Well, 305 is opposite from 20 degrees. Well, opposite, we know it's either going to be sine or tangent. That already narrows it down because sine uses opposite and tangent uses opposite. So it's got to be one of those two. And then x is adjacent to 20 degrees because, here is the hypotenuse, and we're not given the hypotenuse at all, okay? So that eliminates sine and cosine. So we're going to be using tangent. So the tangent of 20 degrees equals 305 over x. And remember, when x is on the bottom, these two switch places. We have to get x off the bottom of the fraction. So x equals 305 over the tangent of 20. So we will divide. So 305 divided by the tangent of 20. And you'll get 837.98 feet. So 837.98 feet. And once again in your assignment, I'm going to specify how many decimal places to round, and when you type in your answers, don't type in the units of measurement, just type in the number. Okay, so then you got a swimming pool is 20 feet across. Okay, so you got your swimming pool. Okay, so we got a swimming pool here. All right, it's 20 feet across. The angle of depression to the deep end is 25 degrees. Okay, so here's the pool. Angle of depression to the deep end. So the depression is going down, okay? Oh, 25 degrees, sorry. Okay. 25 degrees. Okay, how deep is the pool? So we want to know how deep the pool is. Okay, so remember angle of depression. So this is like going down. That's how I knew what angle it was, because it was going down. You know, we got to form a right angle. There's my right angle. Okay, so once again, let's figure out what we've got here. Well, here's my hypotenuse. Okay, I'm not given anything with a hypotenuse, so that automatically means I can't use sine or cosine. Sine and cosine are the ones that use hypotenuse, so that means I got to use tangent. So tangent of 25, okay, opposite is x, and my adjacent was 20. So I move my 20 up and over, and I'm going to do 20 times the tangent of 25, okay? So 20 times tangent of 25, 9.33. So 9.33. All right, my next problem. At 10 a.m. on April 26, 2000, a building 300 feet high cast a shadow 50 feet long. Well, think about where would you see a shadow? You're going to see a shadow on the ground. Okay, so the shadow is 50 feet long. What is the angle of elevation to the sun? So angle of elevation is the angle going up. So from the ground up, okay? So here's where that angle is. It wants to know the angle. We don't know what the angle is. So we can call it alpha or beta. It doesn't matter which one. I'm just going to call it alpha, okay? So once again, I'm not using the hypotenuse, okay? The only ones that use hypotenuse are sine and cosine. So that means I am using tangent. So the tangent of alpha, opposite is across the triangle. It's the furthest away. So that's going to be 300 over 50. Okay. Remember, when you're looking for the angle, because this is kind of throwing everything together now. When you're looking for the angle, that's where you hit the second button. So you do the inverse tangent. Okay. We don't know the angle. So you would hit second tangent and then do 300 over 50. That's what we're going to type in the calculator, okay? And so, like, you'll do that inverse tangent. That's what's going to happen on the calculator, okay? So, inverse tangent, 300 over 50. So, second tangent, 300 over 50. And we get 80.54. So, 80.54 degrees. That's the angle. Okay, so for our next one here. Okay, so this is one of the toughest ones. This is the toughest one in our notes because it's a multi-step problem here. So you have a blimp suspended in the air at a height of 500 feet. So here's our blimp, and it's suspended in the air at 500 feet, lies directly over a line from Soldier Field to the Adler Planetarium on Lake Michigan, okay? So what's happening here is you've got two things here. You've got the planetarium, and you've got Soldier Field. So we're forming two right triangles that are essentially back to back is what's happening. The angle of depression from the blimp to the planetarium is 32 degrees. So remember, depression is like up in the sky because you're looking down, okay? So if I draw this line here, so the angle of depression from the blimp to the planetarium is 32 degrees. And from the blimp to Soldier Field is 23 degrees, okay? So what we know here, if this is 32 degrees, this angle down here is also 32 degrees, okay? And then if this is 23 degrees, this down here is 23 degrees, okay? I had to change some things up this year. Normally, you would have already learned this because it's a rule about parallel lines and transversal lines, but we had to move some chapters around. So just for right now, take my word for it because of this line and this line being parallel, and this line and this line being a transversal. So these are considered alternate interior angles. But for right now, know that this angle and this angle are going to be the same, and then this angle and this angle are going to be the same. So when that happens, you know that the kind of like their opposite angles are going to be, you can do that, okay? And we'll kind of learn about that more specifically later on, okay? So back to dealing with the triangle, okay? So the 32, you got the 32 degrees, okay? Now, what we're going to do is we're going to deal with this triangle first, okay? And then we're going to actually find this side right here, okay? Because we know, we're going to use the 32 degrees. We know that opposite from 32 degrees is 500, and we're going to find that side that I just highlighted, okay? So opposite from 32 is 500, and we're going to find adjacent. So we're going to be dealing with tangent, okay? So the tangent of 32, opposite is 500, and then we're just going to call this side x, okay? So those two are going to switch places, so because x is on the bottom, so x equals 500 over tangent of 32. Okay, so 500 divided by tangent of 32 is going to be 800.17. Okay, actually, let's just round it. We'll just round it to a whole number for right now. So we'll just say 800. As a whole number. We'll keep it simple. So 800. So rounded to the nearest whole number is 800. Okay. So x is 800. So this side right here is 800. Okay. All right. Now let's do this triangle. Okay. So same thing. We're going to do tangent again. We're going to do the tangent of 23. Opposite is 500, and we're going to do this x, okay? So once again, x is on the bottom, so they got to switch places. So x equals 500 over tangent of 23, okay? So 500 divided by tangent of 23. And that's going to be, we're going to round that to 1,178. So 1,178. So x equals 1,178. Okay. Now, it wants to know the distance between Soldier Field and the planetarium. So all we have to do is add those two numbers up. So 800 plus 1,178. So 1,178 plus 800, and we get 1,978. So 1,978. Did I do that right? I just forgot. Yeah, 1,978. So that is our total because we just added those two together. So basically, you just did two triangles and added up your total of their bases. And that's the toughest problem that you'll have. Okay. Next one, a guy wire, 80 feet long. Now, a guy wire is what you see when you see the really tall towers. So, like you've got your, if you've got like your tall tower, okay? And then the guy wire is what you see that's attached to the tower that helps hold it steady to the ground, okay? So that's what a guy wire is. All right. So here's our right triangle. It makes an angle. So the guy wire is 80 feet, and it makes an angle with 25 degrees to the ground, okay? It wants to know how high the tower is, okay? So this time we are using hypotenuse, which means we're going to use sine or cosine. We got to figure out which one. So basically, is X adjacent to 25 degrees or is X opposite from 25 degrees? Because that determines if it's sine or cosine. So X is opposite. So we're going to use sine. So sine of 25 degrees. So opposite over hypotenuse. So we move 80 up and over. So we do 80 times sine of 25. So 80 sine 25. And we get 33.81. So 33.81. Okay. All right, our last two are just a little bit more challenging. A straight trail with an inclination of 17 degrees leads from a hotel at an elevation of 9,000 feet to a mountain lake at an elevation of 11,200 feet. What is the length of the trail? Okay, so what we've got here is you've got, if you think of it like this, you've got, here is your hotel, and its elevation, so basically you've got sea level down here. The hotel is at an elevation of 9,000 feet. And then you have a mountain lake, and its elevation is at 11,200 feet. And you've got this trail that's leading up to it, okay? So what we got to do is kind of form a triangle out of this. So if we go straight across, there's our triangle. Now it says the inclination is 17 degrees. So here's our 17 degrees. And we're wanting to know the length of the trail. So we got to figure out, basically, using the 9,000 and 11,200, how do we use that? Well, if we subtract them, if we subtract those two, that will give us this right here. So if we subtract those two, we'll get 2,200. And then, of course, that's opposite because that's going across. So that's opposite. X is your hypotenuse. And now we can use sine. So sine is 17. Opposite is 2,200 over X. So now, since X is on the bottom, we got to switch places. So X equals 2,200 over sine of 17. So 2,200 divided by sine of 17. So we'll get 7,524.67. So 7,524.67. Okay. Last one, very similar to this. Okay. So you've got a security camera in a bank is mounted on a wall 9 feet above the floor. Okay. So here's our security camera. It's mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? So here is the wall over here on the other side. Here's our room. Okay, so it's directed to a spot 6 feet above the floor. We know that the wall over here is 12 feet away. Okay. We're making our triangle here. And if I kind of connect here, I'm kind of making another triangle right here. We know, so the angle of depression, we know that this here, this is what we don't know. So this is, we'll just call it beta right there. Okay, that's the angle of depression because it's the angle going down. I know that this is also 12 going across. So if the total is 9, and if we know from here to here is 6, that means that little part has to be 3. Okay? So now I can do, dealing with this triangle, I can figure out beta. Okay? So 3 is opposite. This is my hypotenuse, which means I don't know the hypotenuse. Okay? So therefore, I have to use tangent. So tangent of beta, that's what we're trying to figure out. Opposite is 3. 12 is adjacent. So remember, since you're looking for the angle, you have to use inverse tangent. So we'll hit second tangent 3 over 12. So second tangent 3 over 12. There's your angle, 14.03 degrees. So 14.03 degrees. Remember, anytime you're looking for the angle, you have to hit second and then whatever your trig sign is.